Okay, let's put all this together now in problem 44, page 233. It says find the zeros and then factor this third order polynomial. So let me do that. Let me start from the top. Let me essentially make use of the information that we used in the three previous videos to go ahead and find the zeros of this third order polynomial. Let's start by saying this is a third order polynomial. So we are looking for at most n zeros, where n is 3 real zeros. We better not find more than 3. Finding less than 3 might be okay. 2, let's use Descartes' rule real quick. Descartes' rule, if I just go up here, I've got I've got one sign change for f of x. So Descartes' rule says there is one positive real zero. So now we know this search will not be for naught, right? There is one positive real zero. We should be able to find it. Maybe it's rational. We're going to hope that it is. Down below here, I'm going to just kind of sneak in f of minus x is minus x cubed plus 8x squared minus 11x minus 20. And so there's 1, 2 sign changes for f of minus x, and that means there's 2 or 0 negative real roots. So the situation here, real zeros. Okay, so the situation here is either I've got 3 real zeros, 1 positive, 2 negative, or I've just got 1 real 0, and then the other 2 would actually, you'll find later, the other 2 would be complex. Because after all, we're looking for at most 3. So this Descartes' rule tells us, yeah, you might find 3, you might find 1 real 0. So let's move on. Let's go ahead and now use the rational root theorem to go find all the candidates of the rational roots. So in order to do that, I'm going to say that p, which is the numerator of the potential rational roots, is among the factors of 20. And I'm going to now say yikes, because there's a lot of factors of 20. There's 1, 2, there's 4, there's 5, there's 10, and there's 20. And then I'm going to go do the same thing for q, the denominator of that rational root. Luckily, there is only one factor for the coefficient on the nth term, which is 1. And so that says that p over q doesn't equal. It's in fact, I wish I hadn't used it. It's an element of. It's an element of the set 1, 2, 4, 5, 10, 20. I hope that didn't run off the screen. It might have. But I also hope we don't have to use 20. So at this point now, we're going to just kind of search. If we can just grab one root out of this, we can probably find the others pretty quickly. And I'm just by inspection, I'm going to say, by the way, if x is equal to positive 1, I've got 1 plus 8 plus 11, that's 9, plus 11, that's 20, minus 20 is 0. So f of 1 is 0, 1 is a root. X equals 1 is a root. And therefore, by the factor theorem, x minus 1 is a factor. And that's great, because what I can do now is I can factor x minus 1 out of this third order polynomial. It will leave me a second order polynomial. It will leave me a quadratic, and we have 9 different ways. Well, we have 3 different ways to solve those, and hopefully we can just factor it by inspection. So in order to do that that reduction, rather than polynomial long division, we're going to do synthetic division using x minus 1 as the divisor. So we're going to set this up to look like this. We've got to just write down the coefficients here. 1, 8, 11 minus 20. Draw my little line, and now I'm off and running. I bring down the 1, multiply by 1, put it there, add these up, I get 9. Multiply by 1, put it there, add these up, I get 20. Multiply by 1, put it there, I get 0. And as expected, the remainder is 0. And what this says then is that f of x, this third order polynomial, can be rewritten as x minus 1 times x squared plus 9x plus 20. All right, and as I hoped, we can go further very quickly because this can clearly be factored. 4 and 5 multiply together to get 20. 4 plus 5 add together to get 9. And so I can, as I was asked, I can factor f of x in the following manner. I'm going to have a plus there, sorry, and a plus 5 here. And therefore I can say that the zeros are the numbers that make each one of these individual factors 0. So it's x equals 1, it's x equals minus 4, it's x equals minus 5.